detailed add task dialog using a bottom sheet dialog, which is fantastic. We just need to finish off the dialog by completing the code to show and hide the add details edit text when they click that button. And then we need to do the programming code to actually save the task with whatever values the user has in the dialog. After setting the content view, let's go ahead and make some line breaks before the .show, of course, and we have access to all the views through our useful dialog binding. So we'll do dialog binding dot, and then it's our button show details, and then we'll do a set on click listener on this, and we'll just make a line break. So in the Google Tasks app, they just have a one-time thing where if they press that button, the add details field shows, and then it shows forever. I'd like to go one step further than that and actually have it as a toggle. So if the add details text field isn't showing, we show it, but if it is showing, then we can hide it, as users do sometimes accidentally press things, and they might not be interested in adding any details. So we'll do that just for a small enhancement. So we can do an if statement, if, and then we want to check the visibility of that edit text. So we'll do the dialog binding dot edit text task details, and then there's a property called visibility, and then we can do double equals to check what it is, and the gone, visible, and invisible properties that attribute can be. It comes from the view class, so with a capital V, view, dot, and then we have visible. So if it's visible, we want to hide it, else we want to show it. So let's do dialog binding dot edit text task details dot visibility single equals to assign it, and we'll assign that to view.gone if it's visible, and I'll copy all of this line and I'll paste it to there. Otherwise we want to show it if it's not visible. So that completes the logic that we need to show and hide the button. Now, is this a bit long and cumbersome? Dialog binding dot edit text task details 3 times? Possibly. Another way we could do this actually is using an if expression. So instead, let's try this approach. Dialog binding dot edit text task details dot visibility equals, and then we'll do the if statement here. If the dialog binding dot edit text task details dot visibility equals view dot visible, then view dot gone, else view dot visible. Do it as a one-liner, and I can delete this. Doing an auto format will put that on a new line, as it is quite a long line, but that's okay. So you're free with your code to refactor it in a way that is clean for you. I wasn't a fan of having this 3 times, okay? So this is an if expression. If it's visible, then the value is this, else the value is this. So that's another way you can do it. But that's all the logic we need to show and hide that. Before testing this, I will go back to the layout file and make it gone by default. So visibility gone. And we can run this now. And when I click the floating action button, we have no add details initially. And when I click the button, then we can see it shows. And then we can toggle that, which I think is quite nice. Okay? So the only functionality we need to do now is to actually save the task by capturing the value of the new task field, the add details field, if applicable, and the value of the star icon. So we'll go back to main activity. So we need some more code now for the save button. So dialog binding dot. Okay, I can see we haven't got an ID for our save button, so that was something that I forgot. No problem. In our layout file, quickly add an ID, button save, and now would be a good time to auto format. And quickly extract that string. So this is our dialog add task save button. Okay, so back to main activity. So it's dialog binding dot button save dot set on click listener. And here we can go ahead and save the task in our database, which is very exciting. So we're going to need, first of all, to create a new task object based off all of the values. So val task equals a new task object, and then we'll do a new line. And so our title is going to be our dialog binding dot edit text task title dot text dot toString. Our description is going to be our dialog binding dot edit text task details dot text dot toString. Now we do have a slight problem. If I just go back to the emulator, we don't have the functionality where when we click the star, it toggles between on and off, is starred, is not starred. And there's going to be a bit of code to actually have this be a toggleable button, one that can be on or off. So we'll actually do the is starred logic later, but don't worry, we will come back to it soon. I just want to keep things simple to finally add some tasks to our database from within the app itself. So we're simply going to have, when they click save, we make a new task with the title being the new task field, the description being the add details field, and then saving that task in the database. So back to Android Studio, we now have a task, and we can simply do our lazy task variable dot create task and pass in that task. What am I forgetting? Threading. We need to do this on a background thread. Nice and easy, lowercase t. And we can put this command inside there. And at the moment, we're not doing any updating of the UI. We'll use our database inspector to confirm this is working nicely. So for now, that is all the code we need to add tasks to our database from our bottom sheet dialog. So let's now go ahead and run this and try adding a few tasks into our database and then confirming that they are in the database through the database inspector. So clicking run, we'll do add, and then we'll do a simple task without a description. So my brand new task, and then save. No crashes, however, we didn't dismiss the dialog when we clicked the save button. So let's quickly go ahead and do that. We'll call dialog.dismiss. But before we run this up again, let's go to app inspection, select the process, give it a second, pixel 7, yep, and go on the task table there, double click, scroll to the bottom, my brand new task, fantastic. I wonder if we check the live updates field. And then run our app again. And I'll quickly go back to the app inspection tab first. It's saying closed at the moment because we haven't done any database operations yet. So it will always say closed until our first tasked out operation. So let's go ahead now, add one more task. This time without a description. So yet another task, and these can be some task details, and then save. And you can see our database comes alive. Scrolling down, yet another task, some task details. I can check live updates like I did before. Add another task. Hello, how are you? And then click save. And scrolling down, that updates in real time. So this is absolutely fantastic. We have a nicely styled add task dialog using the Material 3 bottom sheet. We have a show and hide toggle for one of our text fields, and saving these tasks in the dialog adds them to our database. Things are working well. We have a bit of work to do to come back to doing the is starred functionality. We want it so that when we click this button, it toggles into an on state with a filled in star. But I think we can do this a bit later. It's going to be far more exciting for now to move on to actually displaying and listing these tasks within the app. So let's move over to doing that next. Time now to show our tasks list. I'm in the tasks fragment, and I've also got the fragment underscore tasks layout file open as well. Just clicking into that. It actually has been quite a while since we last made any sort of list in our projects. It's been so long, in fact, that the last time we needed to make a list was our bucket list challenge, quite a while ago now, and then we were still working in Java. So this tutorial is going to be a fantastic chance at revisiting the recycler view to make a beautiful, completely custom list, but this time implementing it in Kotlin, and hopefully seeing how much quicker and easier it is to do in Kotlin than it was when we did it in Java. So in the layout file first, we've got this placeholder text view that says this will be the tasks fragment. We can go ahead and delete that. Now we could maybe do the recycler view inside here, widget.recyclerView. However, for the time being, the recycler view is going to be the only widget in the layout, and so instead we can actually replace the constraint layout, our parent view, with the recycler view. So we'll do exactly that, recycler view, autocomplete, and we'll leave the layout width and layout height as match parent, so it fills our fragment. And I am going to fly through some of the previous learning of recycler view. I know it's been quite a while, and I don't expect you to have it all memorized. However, I don't want to spend teaching time covering the same concepts. So one of the concepts we covered was the idea that you need a layout manager, otherwise the recycler view won't work. So if you start typing layout manager, and it's this app:\layout manager, and we just want ours to be a vertical list rather than a grid or anything else, so we can choose the linear layout manager there, and that will be fine. And in order to have a custom layout for each item, we're going to be shortly making a separate layout file for our individual task items. And there's a useful way that I showed you where you can preview how your recycler view will look with this custom layout. So we can do tools for the tools namespace, and then Alt-Enter to import that. And then it is list item equals, and then we can do @layout, and then we can do a new layout file, which will represent one task. And I'll call this item_task. we're getting an error because we don't have this layout file yet, but I can use the error to create the file. So Alt-Enter, create layout resource file, item task. Yes, I think we'll leave the root element as a constraint layout. I'll press OK. And moving to split view, we can actually design the layout for an individual task here. So we're not going to go into too much detail styling it just now. In fact, initially, we'll just have a text view that displays the task title. So we'll make this match parent, and the height can be wrap content. And we'll give it an ID, because we will need it to set the task title on this text view. So this can be the text view title. And we'll constrain it vertically by doing top to the top of the parent. You know what? We will go ahead actually and show the details. It doesn't take too much time. So I'll copy all of this, change this for text view details. This can now be top to the bottom of the text view title. And I'll put some tools text just to see what it looks like. So tools, add the namespace, and then text. So this can be our task title. I'll copy that into the text view details, and this can be our task details. I think I'll squeeze the whole thing in with some padding on our parent container, so maybe 12 dp. And I'll make the text size on the first text view a bit larger at 16 sp, and then I'll make the text size for the details a bit smaller. We will improve the styling of this, including having the checkbox where they can check off the task, but for now this will just at least show us the details from our database, which will be quite useful. So I've really flown through that, a quick item_task layout for our individual tasks, but at least when we get our list working, we'll be able to see the details of our tasks that are saved in our database. So back to fragment_tasks layout for our individual tasks, but at least when we get our list working, we'll be able to see the details of our tasks that are saved in our database. So back to fragment_tasks. For some reason, we're only seeing one task there, and that is because, and this is a very common mistake I find myself making, our item task is set to match parent for the height. If I change the height to wrap content, do a quick auto format, and then head back to fragment_tasks, well, then I can see a list of our new task layout there, which is fantastic. And we don't actually need the opening and closing tag, as we just have the recycle view in this layout, so a self-closing tag will be enough. We'll also need to give the recycle view an ID. So ID can just be simply recycle view. We've only got one, auto format. And then with a simple recycle view in our fragment_tasks layout and this item_task layout for our individual tasks, we're in a really good position now to jump into the recycle view, but this time doing it in Kotlin. So let's do that in the next tutorial. I'm inside tasks fragment, where we'll be setting the recycler view adapter. First of all, though, we need to actually make our recycler view adapter. Over in the project pane, we've gathered up all of the files relating to our database neatly into a data folder, which is nice and tidy. As we're going to be making yet another file relating to the user interface, our tasks adapter, it might be useful to start doing something with the packages for our UI classes and files. For example, it might be nice to gather up all the things relating to the tasks list, that's our tasks fragment and our tasks adapter, within maybe a tasks folder. However, having that next to the data folder, it's going to kind of not make sense with our package hierarchy. So a really good practice thing that I like to do, and lots of engineers do, if you've got a package for your data, well then we can have another package for all of our UI. So right-clicking on the top-level package, the Get It Done package, and doing New Package, we can have a folder for all of our UI files, our user interface files. So I'll call that UI, and I'll select both main activity and tasks fragment and move them both into there to refactor that. And I'll say yes to refactor. It just takes a moment for the binding classes to find themselves again after slightly moving location. It's a good thing to do to make sure that all of the package imports have changed correctly. So it's worked for our tasks fragment. Let's make sure main activities worked. Yep, that's fine. So now we have this nice separation between UI files and data files. And now within the UI folder, I can make another package for all things to do with our tasks list. So I'll do new package in the UI folder. I'll call this tasks. And then I can move the tasks fragment into here. So refactor. And then I'll open up that folder, that package. And then I can right click and do new Kotlin class and file. And this will be our tasks adapter. So once we get our list of tasks from the database, we need to adapt those into the task items, that item_task layout that we made in the previous tutorial. We'll create the new file of type class. Now this is going to be a recap of making a recycler view adapter and a view holder, the inner view holder class, that we've done twice before, but the last time we did this it was in Java. I'm going to go through this fairly quickly. Making recycler views does involve a little bit of boilerplate, but we've covered this at least twice before, and hopefully what you will notice as I do this is how much less code it is using Kotlin. It's a lot more succinct. So the first thing we need to do is make sure it extends the recycler view dot adapter, and then we need to specify what we're adapting it to, what's the type, and we put that inside these diamond brackets. So there's space here where my cursor is flashing to put the view holder that we're going to make in just a moment, and then we can do the curly brackets as it's a class, an abstract class, not an interface. And before going any further, we will go ahead now and make the inner class for our view holder. So making some line breaks inside the class curly brackets, and we'll do inner class, and this can be our view holder. And we can actually pass in the whole binding. So if we make the one constructor parameter be binding of type item task binding, and you're going to see in just a moment when we create the view holder how we go about inflating that and passing it in. But then having access to this binding property inside our view holder is going to make it really, really easy to set all the things in the item underscore task layout that we made in the last tutorial. We actually need to make it val binding, an actual property that we can refer to. So val binding, item task binding, and this is going to extend recyclerView.viewHolder. It's an abstract class again, so we do the constructor brackets, and it needs one thing, an item view, and we can simply do binding.root for this. So this is something new. We hadn't learned about view binding the last time we did recycler views. You're going to see in a moment when I complete the rest of the recycler view adapter how relatively straightforward it's going to be to inflate an item task binding, pass it in, and then set all the things that we need. So that's our view holder. I'll do the curly brackets for this new inner class, and we'll make one function called bind, and that will take a single task, our task class that we made in our getItDone.data folder. And then in just a moment, we'll come back to this bind function and we'll set all the things on our binding. But for now that we've got this inner class, this view holder, I'll just put it in a bit of space, we can refer to this in the adapter type brackets. So this is a tasks adapter that's going to adapt to a view holder that we just made below inside our tasks adapter. So that one there, that gets rid of that error. And the final error is because we need to implement the 3 mandatory override functions of the tasks adapter. When I click on the error and do Alt-Enter, implement members, it's the onCreateViewHolder, onBindViewHolder, and getItemCount. And so when I press Enter, it puts those 3 functions in for me. I'm going to cut them and put them on top of my inner class. It's just an organization convention that I like to stick to. Okay, inner class is at the bottom, but our class functions on top. And I always like to have getItemCount on top to remind me that the first thing that this will be doing is checking how many items it has. Okay, so there's our 3 functions. It's already a little bit simpler. Back in the Java days, we had to call this a static class and all kinds of funny things. It's a lot more succinct in Kotlin. So what is it we're going to be adapting? Well, it's going to be our list of tasks. So I'll make a constructor property. So val tasks of type list of task. So we'll be passing in the list of tasks straight from the database. So getItemCount, or we can simply return the tasks.size. We'll have a view holder for every item in our tasks list. But we can use all the goodies of Kotlin. We can change this return to an expression body. So getItemCount of type int equals tasks.size. And you know what? We can remove the explicit type declaration. So we can turn the getItemCount function into a one-liner, nice and clean. And then we need to do a bit of work in the createViewHolder and the bindViewHolder functions. So for onCreateViewHolder, we're going to be returning our viewholder class below. And then inside the constructor, we need to pass the item task binding. And to do that, we can do item task binding.inflate. And we want to be using the 3 parameter version, the one with the inflator, the parent, and the attached parent. So the inflator first. The way you can get an inflator is using context. So this is the only complicated bit of it for me, the one that I previously had to refer to as I used to forget, although I've got it memorized now. So you can get the layout inflator by doing capital L layout inflator dot from, and then you need context. And fortunately for us, we have context from our parent. You see that parameter there, the parent view group. So we can do parent dot context. So that takes care of the first parameter, our layout inflator. We just need to do the other 2. So we need the parent and the attached parent. So we can inflate it into the parent that we have above, that parameter there. That's what we'll put this layout file into. But we say that we don't want to attach it to the parent. Attaching means something else. So in this case, we say false. And that's what we need to do to return a view holder. So let's recap that. We create a new view holder instance, this thing here on line 21. And then we do item task binding.inflate. We're going to inflate our binding. This is something new that we didn't do before when we were doing recycler view adapters in Java. So item task binding.inflate, and then it's the 3 parameter version. We need the layout inflator, which we get using this bit of code here. To make it clearer, because there's quite a lot going on, you could cut that on the line above, assign it to a variable called inflator, and then pass it in. Maybe that makes it a bit more readable to see what's going on, or you're perfectly fine to do it as a one-liner. It's entirely up to you. I think I'll leave it on 2 lines as it's nice and clear. So item task binding dot inflate, and then 3 parameters: the layout inflator that we got on the line above, the parent view group that we have available to us in this function's parameters, and then attached to parent must be false. So for me, that's the difficult part, and still it's only 1 or 2 lines. So then for the onBind viewHolder method, it's very simple. We do holder dot bind, and then we just pass in the correct tasks for the position that we're in. So that will be simply tasks, square brackets, position. Nice and easy. And that's all the code we need for our recycler-view adapter. So now all the magic happens inside this bind function where we actually set the values. And for now, there's just a couple of things we need to set. We have binding.textViewTitle.text, and that will be equal to our task.title. And I'll duplicate that line, and we have textViewDetails equal to our task details, or description in our case. Maybe later on we'll go back and change that in the database. It's fine as description for now though. And that's all the code that we need. We have a couple of suggestions. The binding property is only used here, so we could and should make that private. So I'll make it private there. And the same for our tasks. It's only used inside this adapter, so again we can go and make that private. So, task adapter passing in our tasks list, and that extends the recyclerView.adapter abstract class, where we specify what we're adapting it to. And that's our custom tasks adapter view holder that we have here. Then we implement the 3 members that we need: get item count, and that's equal to our tasks.size. Then we create this view holder. We need the layout inflator to do that. And then we do the item task binding.inflate with the 3 parameters. Arguably, this is the most complicated part of the whole process. And then onBind view holder is very straightforward. We call our holder.bind function that we have here. And then we just pass in the correct task by doing tasks, square bracket, position. And then all of the code to set the individual item happens in our bind function. So now that we have our tasks adapter, we can head back to tasks fragment. And then in the onViewCreated function, we can do binding.recyclerView.adapter equals our new tasks adapter. Now this is going to need a list of tasks. I'll just make a quick line break. So we'll do tasks equals, we'll do a named argument. And rather than making this tutorial longer than it already is by doing the database work, we'll just do a quick hard-coded list of tasks just to show this working. So list of, and then again I'll make some line breaks inside these brackets, and we'll just do a few dummy tasks. And then we can run this code now to make sure that everything is working well with our recycler view in the layout, our item task layout that we made for each individual task, and our new tasks adapter that we have now written in Kotlin. A lot more succinct than it is when doing it in Java. Hopefully you've noticed. Okay, so let's go ahead and run this and see what happens. Written in Kotlin. Recycler view in the layout, our item task layout that we made for each individual task, and our new tasks adapter that we have now written in Kotlin. A lot more succinct than it is when doing it in Java. Hopefully you've noticed. Okay, so let's go ahead and run this and see what happens. Okay, and straight into our tasks fragment that we have in our view pager, we can see first task, another task, and another one. So our recycler view is working as expected, and we're now in a good position to pass in the real task.